Hello students, welcome back. Now let's begin module 2. Excuse me, it's not module 2, section 2. Section 2 of this module, probability distribution. What is a probability distribution? A probability distribution is a combined concept. We begin with two functions, a probability mass function defined like this, and a cumulative distribution function defined like that, and put these two together as a single concept. That's what we call probability distribution. So a probability distribution is basically PMF and CDF put together. Now what is PMF? It's a probability that the random variable capital X taking the numerical value small x. So capital X is equal to small x. How about CDF? It's the probability that the random variable capital X is taking the numerical value small x or less. So it's a cumulative probability because of this or less part. So here we have capital X is equal to x. Here we have less than or equal to x. That's the difference. But then again, it's really hard to understand what is what just by looking at these symbols because they are so confusing here. We have small p and big P and capital X and small x, which is which. It's really hard to follow. So let's begin examples, and I hope examples will help you understand better. Okay, let's go back to our primary example, an urn model. An urn contains 5 red, 3 green, and 2 blue balls, okay? And the sample space, of course, is RGB. And please note that none of the outcome is numerical value, but we can assign numerical values like this, or that, or many other, but these three are sufficient. And let's consider the probability mass functions here. Okay, let's begin with this one. Let's consider random variable x. So we have three possible outcomes, 0, 2, or 3. See, we have RGB, and we are assigning 0, 2, and 3 as payoff values, the numerical values. So the possible numerical values are 0, 2, or 3. There's nothing else. And how do we express all these? One good way to do that is to use a table form like this. Please pay attention to this table on the left-hand side. On the top, we have possible numerical values, 0, 2, or 3, which correspond to RGB, and those are the top. And then the probabilities go to the second row, 5/10, 3/10, 2/10. 5 red, 3 green, 2 blue. So those are the probabilities. And of course, otherwise impossible. So otherwise the probability is 0. This part, which I just highlighted, is not really necessary. So many textbook authors just skip this part, but I usually put this one in. Otherwise, the probability is 0. Now this problem specifically asks you to use small f for your the probability mass function. So I have small f of x here, but most typically you're going to use small p for probability mass function if specified otherwise. But then again, here we have 3 random variables, x, y, and z. And if I use p all the time, it can be confusing. So I'm using different characters here. Most of the time it's going to be p, small p, but in this case we are going to be using f, g, and h because we have 3 random variables to consider. In short, this part is not that important. This part is. This part is important. We have the possible numerical values and corresponding probabilities. You can write it like this as well. Capital X for the random variable, and it can take 0, 2, or 3. And the probability for that, 5/10, 3/10, 2/10. Otherwise impossible. Another way to express the same thing, vertical table. Instead of possible x values and possible probabilities like this, possible x values here, possible probabilities like that. Or if you use the other way around, x comes to the left and then f of x comes to the right, it's going to be okay. But in any case, you can use one of those tabular form, horizontal table like this, or vertical table like that. Horizontal table is a little bit more concise, and I can complete it in a very short line. That's a pro. But then again, if you have a lot of colors, then horizontally I may run out of space. Vertically, it's a little bit better. Even if you have, 20 different x values, you can just arrange them all in vertical fashion. So for a more complicated case, we use vertical form, and for something concise, horizontal form. But either way, you should be able to see the correspondence one way or the other. Another good way is to use piecewise defined function form, and that is very algebraic. And the student who already did all the college algebra and then did very well will like this method, and those who didn't will not like it very much. Still, our textbook author uses this form as well. Now, if you go over to a little higher level, for example, I'm teaching Math 3680, applied probability and statistics for a mathematics major, math and some IT students. There, I use this one almost exclusively. But here in 1680, if I go a bit too much here, students will begin to get confused. So I'll try not to do this too much. You can still see this kind of expression in MyMathLab exercises. In MyMathLab, all three types of show up. This kind of piecewise defined form, or horizontal tabular form, or vertical tabular form, they all appear. And basically what we have is the table, and then we have a bunch of blank boxes, and you have to fill in those blank boxes. MyMathLab will keep you busy, so let's not go too deeply into this. Let's just complete this problem. Let's go to the graph of this thing, and the graph looks like this. We have three colors, RGB, so we have three masses. And what are those x values, possible payoff values? Those are 0, 2, and 3 respectively. Do you see this? 0, 2, and 3. Those go to horizontal, and the probabilities go vertical. Probability for red is 5/10, probability for green is 3/10, and the probability for blue is 2/10. So we have those probabilities vertically and x values pay off horizontally. That's the graph of a mass function. Which is most important? In my opinion, the tabular form is the most important and the most useful. Either horizontal or vertical. Okay, we went through the first example. Now, can you do the second problem here? Well, okay. That's a problem. I just copied and pasted. And then, okay, I want g of x, and then this is random variable y, so let's change all these accordingly. And let's work out. What are the possible payoff values? For the second random variable, the possible x values are negative 1.5, 0.5, and 1. Those are possible payoffs. Previously 0, 2, 3. Now negative 1.5, 0.5, and 1. And we must have negative 1.5, 0.5, and then 1. What are the probabilities here? Well, probability will stay the same. 5 red, 3 green, 2 blue, so they'll stay the same. And there you go. That's the table. Or you can do this vertically. So this is your g of x. And then possible payoff values are -1.5, 0.5, and 1, not 0, 2, 3. So -1.5, positive 0.5, and then positive 1. This one is -1.5. This one is 0.5. And then as for the probabilities, well, they'll remain the same because we are talking about the same urn and same color distribution. Let's go to the answer key here. Here, and then the table form, the same thing you saw before, possible payoffs and the probabilities, either horizontally or vertically, whether you use x g of x or random variable and probability of that random variable here, it doesn't matter too much. I'm not going to take off humongous deal of points here for missing this part, if at all. But if you miss something here, that's going to be a heavy deduction. Otherwise, 0, that's not really necessary. So if you miss this, nobody will take off any point. If you do some MyMathLab exercises, then each spot here will be blank boxes, and you'll have to fill those in. You have various problems there, either in horizontal form or vertical form, or piecewise defined form. Oh, excuse me. Yeah, all these show up in MyMathLab exercises. How about the graph? Okay, I'll show you the graph. Horizontally, we have x values, so -1.5, 0.5, 1, and then vertically we have probabilities. Red, 5/10, green, 3/10, blue, 2/10. How about the next problem here? Here, how many possible payoff values are there? We have 3 colors, but the possible payoff values are 2. Because red and green, they both have -1.25. So the table is actually simpler. We only have 2 possible payoffs. So we have -1.25 and 4.75. And then -1.25, either red or green, so 8/10. 4.75 is blue, that's 2/10. Otherwise, 0. You can do this horizontally like this or in vertical form. It doesn't matter. They are pretty same. And as for piecewise defined form, again, it's simpler. When x is -1.25, 8/10, so equivalently speaking, 4/5, and then 4.75, 2/10, so equivalently 1/5. Otherwise, the probability is 0. Here's the graph. We have only 2 dots. Not 3 dots for red, green, and blue, but 2 dots for 2 payoffs. Red, green, these two colors were combined into a single color here. And the probability goes all the way up to 80%, 0.8. Okay, so much for an example on the probability mass function. And we're going to have to discuss the cumulative distribution function shortly, but looks like we had better do that in a separate video, so let's stop here.